Okay, so the question is the following propositional statement is okay. So this is the propositional statement that is given to us, and we have to tell whether this propositional statement is satisfiable but not valid, or valid, or it's a contradiction, or none of the above. Okay, so we have to apply whatever we know about mathematical logic and tell whether it's satisfiable. So what is satisfiable? The statement is satisfiable if you can give truth values to p, q, and r and make this whole thing true, then it is satisfiable. And what about valid? Valid is when it is always true. Tautology, that is valid. What about contradiction? When this thing is always false. So you have to play with this and find out what it is. So let's do that. So I'm going to write it down. So we have P implies, and then we have Q or R. Okay, and then this whole thing implies P and Q implies R. All right. Now what I'm going to do is the same standard thing that we do again and again, which is used, I think, like a lot of times. P implies Q is written as not P or Q. That's what I'm going to do. So I'm going to write this thing down as not P or this whole thing. Okay, so this becomes not P and this whole thing, Q or R. Alright, like this, and this thing is applied here, and I'm going to do the same thing again. So out here, this is this P, okay, this whole thing. So not of P and Q or R. That's what I have. And in this case, what I'm going to do, I don't need these brackets now, right? Because these are all ORs. So I can just simply write it like this. Okay, and then this thing is, so now I can open this one, and if I apply the De Morgan's law, so what is De Morgan's law? This becomes not P or not Q. Okay, and everything else remains the same, not Q or R. Okay, so that's what we have got so far, and I would like you to notice this thing. So we have not P here, we have not P here, and we have this R here. Okay, and we have this R here, but what is different is that we have Q here, but out here we have not Q, and in both the cases we have these OR signs. Okay, these OR signs. So what I'm going to do is I'm going to bring this not P and R together in both of them, out here also and out here also. I'm going to write them together. So what this becomes is not P or R or Q. Okay, this thing implies not P or R or not Q. Okay, this is what I can write. Now what I can do is this whole thing is present in both of these. Okay, out here and out here also, this thing, and then we have not Q or Q and or not Q. So instead of this whole thing, what I'm going to do is I'm going to write S. Instead of this whole thing, I'm going to write S, and this gives me S or Q. S or Q, because I've replaced this thing with S, implies S or not Q. Okay, so this thing now looks quite simpler than what we had before. Okay, and this thing must be easier to analyze as compared to what we had before, and let's see what we can do about it. So we have to check this implication, whether it is always true, whether it is always false, or whether it is satisfiable, which means that for certain values of these variables it can be true. Okay, so let's so this is implication, which is basically if P then Q, right? That is implication. P implies Q. And so what we do in these cases is we start with assuming that if this is true, then whether this is true or not, okay, whether this is true or false. If P is false, then Q is true or false. So if P is false and Q is true, if P is true and then Q is also true, then this implication is definitely true, okay. And if this P is true and this Q is false, then this implication is always false. And if P is true and then Q is sometimes true, sometimes false, then it is satisfiable, because sometimes you have the implication true and sometimes you have the implication false. Okay, so what I'm going to do is I'm going to write this thing out here on the side again so that I can do it out here on this small side. Okay, so what I have out here is S or Q implies S or not Q. Alright, so let's assume that this whole thing is true. This whole thing is true, and then see what we can do about it. So when this whole thing is true, we have two possibilities. Okay, we have three possibilities. Okay, uh, when both of them are true, or when S is true, Q is false, or when S is false but Q is true. Okay, so if both of them are true, then this is definitely true. Okay, if both of them are true, that means S is true, so this whole thing will be true. And okay, so in that case the implication is true. And suppose S is true but Q is false, so let's talk about that case. So suppose your S is true, your S is true, but this thing is false. Okay, then this whole thing is again true. And even in that case, so this will be true and this will also be true, so the implication will again become true in that case, so that is fine. And we saw when both were true, that case was also fine. Okay, so what do we need to do now? We need to do something else. So this time let's do this thing. Let's make Q true. Okay, this time let's make Q true and S false. Okay, so this thing is true still, and this thing is false because S is false and Q is true, so this thing also becomes false. So right now what you get, this whole thing is false. So in this particular case you are getting true implies false, which is not the case with implication. So in that case this implication is not true. So there are cases when this is true and when there are cases when this is not true. So which tells us that it is satisfiable, definitely satisfiable, but not valid. It is not always true and it is not always false.